This is the first review paper, and in the last class we took a look at 1, 2, 3, 4. These first 4 pages here. And this is the last page that we had to do, right? And even though this here looks really tough, I hope that you recognized that what I have here is a number in a bracket, and what I have here is the same number in a bracket. So I can literally cross those two out, and the answer for this is x plus 6. Yeah? So I hope that you guys recognized that. For this one here, this y could cancel with this y. This 2 could cancel with the 4, and I will get 2 up here. This a could cancel with the a, so I'll just get a. So this whole thing just boils down to 2a. Right? And then over here, nothing could really cancel off, really. Oh, well, I guess this 2 could cancel with this 6, and that'll give me 3. Right? So now I'll have 5a cubed all over 3y being multiplied by a. And so the answer is 5a to the 4th all over 3y. Right? We could see here this is really super simple. A lot of people would have wanted to complicate this. But what you have to understand is that we have brackets here, and we have a number inside the bracket. And you notice we have brackets here, and we have the same number in there. When you have brackets, you could just treat that like one thing. Yeah? So this one thing is being squared, and the same thing underneath is not being squared. So it's like if we had one thing being squared over the same thing that is not squared. We could see that this is to the power of 1, so this will cancel with this, and the answer will just be x alone. Yeah? And if it is, you can't remember why, this is the power of indices, where you just when you're dividing, you minus the indices. 2 minus 1 is 1. But we did the canceling thing when we were proving the laws of indices. Remember, we proved all of them. Yeah? So I could just simply cancel this with this and get x plus 7 to the power of 1. But I don't even need to put the brackets, so put that. Right? We have a division here. And what do we know about dividing fractions? Well, you invert and multiply. So that is the one thing I do know. So let's go with v plus 3 over 15. And I'm going to multiply that by invert. So I have the 25 here all over v squared plus 3v. Well, I could see things could cancel with that 15 and that 25. Eh? So how could we cancel that 15 and that 25? Well, 5 times 3 is 15, and 5 times 5 is 25, right? So now what do I have? I have v plus 3 all over 3. And these 3's, you can't do nothing with that, eh? So don't be saying you can cancel off 3 and thing. No, yeah, you can't do nothing with that. You have to take this as one thing, right? That numerator, v plus 3, is all being divided by this one 3, right? And that is being multiplied by 5 all over v squared plus 3v. And wouldn't it be nice if we could have canceled these two as well? This v plus 3 would have been nice. You see how I canceled this 15 and this 25? Cross multiply, you know? So it would have been nice if I could have canceled this somehow with this, and but I could only cancel if you have the same number, like if it was v plus 3, and if I had v plus 3 over here, then I could cancel it off if it was the same number or some multiple of it, right? Like this here, this 15 is actually 3 times 5, right? This 25 was actually 5 times 5. So you can see here what we did is we canceled these 5s, and that's how we got the 3 and the 5 remaining, because it's only the same thing that could get cancelled off, even though it looked different. Okay. So is there any way that I could get v plus 3 to be down here? You can't see this have a v and a 3 and this also have a v and a 3, so maybe something could happen. If this is v plus 3 over 3 multiplied by 5, I could say that I want to get v plus 3 over here, but what will I have to multiply to that in order to get back this? So what I did was I noticed that I'd have v in this term, v squared. So it'd have 2 v's in here and I'd have 1 v in here. So I can literally pull out a v. And when I pull out a v, I'm left with v plus 3. You understand that what I did was I factorized this, eh? Right. And we spoke about this in the last class, where what is factorized? Well, at the end of the day, you have 6. And 6 is a multiple, and you could break up 6 into the factors 3 times 2. So what you did was you factorized 6. Similarly, I have this, and I could see that this is a multiple. This is a multiple, and I could pull out, just like how I see in here that 6, I could see that 6 is just 3 2 times, or it's 2 3 times. So I could literally separate them like this into the factors. I could suppose to see that v is inside of both of them here, so I could separate them like that. V into v plus 3v. 3 alone, yeah? Right. So now I have this 3v here, and this here could cancel, right? So this will be 1 and this will be 1. So now 1 times 5 is 5, right? And then I have 3 times v is 3v, and this is your answer. This is as simple as it is get, 5 over 3v. I have a question for you. If I have v plus 3v, can I factorize this? How? If I pull the v out, right? V times what will give me v? V times what will give me 3v? So we can just see 3 plus 1 is 4v, and but look, we don't know that you can add v and 3v to give you 4v, and yeah, so you see, this whole thing about factorizing is something that we just kind of do in our brain already. Yeah, and it's just a different way of looking at things. So always be aware, if you see the same thing in multiple different terms, always be aware that it could be factorized, right? So let's move on, right? So we had those here. Now we have some distributive law ones, right? And we saw that if I had, in the last class, if I had h into x plus y, all I need to do is take this outside and multiply it by that, so it would be hx plus multiply it by that hy, right? Same thing here, yeah? I could just imagine this as being one big blob of a number. So I'm going to take this big blob of a number and I'm going to multiply it by that, plus I'm going to take this big blob of a number and multiply it by that. Right? So what will I get? This big blob of a number, x plus 2, and I'll multiply it by x first, plus x plus 2, and I'll multiply it by the 1. So now what do I get? I can actually expand this out to get x times x is x squared, and x times 2 is 2x, plus, well, this is multiplied by 1, so this don't really matter, x plus 2, so So now the answer is x squared plus 3x plus 2, right? So I hope, and please Soraya, let me know if I'm going too fast. I done say earlier under some stress this week, so I'm not going to stress earlier out too much. Same thing with this here now. I'll take this and multiply it by the first term. So that's 2b being multiplied by a minus b plus this multiplied by the second term. So that's c getting multiplied by a minus b. Okay? So I could see here that I have 2ab minus 2b squared plus c times a, so let me call it ac, minus bc, right? And I don't think anything here could, AC can't minus from BC. AB can't do nothing like that, right? So you can see here what we did. These are the multiples and these are the factors. And we just took the factors and multiplied them and we got the multiples. If we wanted to, we could have worked backwards. We could have taken this and say, look what we have in common here. We have 2's in common here, and we have b in common here. So pull out the 2b, and you'll have that factorized, right? So factorization is a really, really important rule, and especially coming up in Algebra 2, where we have to factorize quadratic equations, we're going to need to have this skill. Right, you absolutely can, right? And it works out to be the same thing, and that's a great question, because what's she saying here? Like, let me just take the first one because that's the easier one. X plus 2 into x plus 1. Great question, Scotia. So at the end of the day, what she was saying here is you're taking this x and you're multiplying it by what? X, x squared, yeah? Right? And then you're taking this 2 and you're multiplying it by x, plus 2x, right? And then now you take this x and multiply it by 1, right? So you're going to get plus x, and then you take this 2 and multiply it by the 1, so you'll get plus 2, right? But look at what you did, Scotia. What did you do? We took x, multiplied by x. We took 2, multiplied by x. Isn't that the same as taking this and multiplying it by x first? Yeah? So what we did was x multiplied by x plus 2, eh? Yeah, isn't it the same thing? Exactly the same thing, right? So now you can see this here, what we did before. The reason why I did it that way is because I wanted to show you that it's actually the same as the simple ones. When you have one thing on the outside, you multiply it by each thing on the inside. So similarly, it's the same thing here, right? You have one thing on the outside and you multiply it by each one of those things on the inside there. But it works out to be exactly the same as that individual method that you were talking about. In fact, this is where that individual method comes from. Wouldn't you agree? So it's just really like an extra step, you could say. If you could do the individual one, then you're jumping from this step straight to the last step one time. But if you're having problems, just remember that this is multiplied by that. And then that is multiplied by that times 1, right? And that works out to be the same thing. So this is really like an extra step, but this is where it comes from, right? All right, let me just see if anything poke out at here, right? So the diagram below, which is not drawn to scale, shows a circle with center O. So I guess that there is center O. And you notice I'm reading the question in pieces. Yeah? The line UVW. So let me see, where's the line UVW? That is this line UVW, right? Is a tangent to the circle. Alright, I could see that. Okay. So that line UVW is a tangent to the circle. That is nice. And ZOXW, ZOXW, that is this line here, is a straight line. Thanks for telling me that. So they're telling me, they're going out of their way to tell me that this is a straight line. That might be important. So this is a tangent, and this is a straight line, right? And the angle UOX is 70 degrees. Well, okay, they stated that there. Right? Cool. Calculate, showing working when necessary, the measure of the angle OUZ. So we have O, we have U, and we have Z. That is this angle over here. Any idea? Angle O here, you mean here? Yeah. Right? Angle O, because they told us this is a straight line, so that will be 180 minus the 70, which is 110. So we know that this is 110, right? This is the angle that we want. So how does that 110 help us to get this angle here? So this, and therefore this will be 110 on this side as well.
Yeah. So I think because of that,
well, not just because of that. The reason why is that equilateral triangle, and yes, you're absolutely right, is because from the point O, this is a radius, and this is a radius, and these two radii are the same, so it's not an equilateral triangle, it's an isosceles triangle. And yeah, equilateral would have been if all three of them was the same, right? But we don't know if all three of them is the same, but we're sure that these two are equal, which means it's an isosceles, and that means that this angle is going to be equal to this angle, and right? So that means that the angles inside of a triangle are supposed to add up to 180 degrees. So 180 minus the 110 gives me 70 degrees, and 70 degrees divided by 2, which splits up 35 and 35 here. Make sense? Right? And you notice that this is a chord, and this chord subtends this 35-degree angle here, and that same chord also subtends this angle here, so that means you know that this is 35 as well. Right? And if you know that this is 35 and 110, then you know that this is 35 here, and then you can work out these two. If that is 70, you can work out those two quite easily, because this is also an equilateral triangle. Sorry, not equilateral, isosceles. You see how I forgot the two, right? So you can see there is 2 marks, right? So what you had to do is say how you're gonna get your 2 marks. You're gonna say angle ZOU equals 110 degrees because angles on a straight line equals 180 degrees, right? So that is 1 mark you get there, right? And then the next mark you get there is therefore, right? You had to state that ZO equals OU because radii, hence the triangle ZOU is an isosceles. Therefore, 180 minus 110 is equal to 70. Therefore, angle OUZ is equal to 35, which is 70, divided by 2, which is 35. Why? Because base angles in isosceles equal. You notice I didn't write all of the words there. I just write the important words. You don't have to actually make a coherent sentence. I just write the important words. I use abbreviations like that. Like this is an abbreviation for angles, right? And that is just fine. But this is the level in a circle theories question. To get your full 2 marks, this is the level that you had to come with. Yeah. Otherwise, you're gonna lose half mark here, half mark there, all that kind of thing. So make sure that you state all of your reasons. U, where is V? Or U, V, Y. That's this angle over here. How are we doing that? U, V, and Y. This big triangle here.
Yeah.
Yes, You can see it's 3 marks, so it might be a little more working. So maybe you had to pass through and work out all kind of different things. So maybe it might not be a straightforward answer. Alright? So let me hear what you do. Let me hear. Don't spit it out. Don't for it to be wrong. U is 90 degrees. Well, U is 90 degrees because this is a tangent and this is a radius. And we know that the tangent and the radius will form an angle of 90 degrees. So therefore, this huge triangle is a 90-degree triangle. Yes? So we can say the angle U equals 90 degrees because tangent perpendicular, look how I write in the word perpendicular to radius. So good. No. And this is it, right? The angle, I mean, look, is the angle U this one? Is it this one? Is it this one? You know? So really and truly, what I should say, I shouldn't say the angle U. What I should say is the angle YUV. And YUV. So that's this big angle here. And? Yeah, so YUV. So that big angle there is 90 degrees, yes. And this is 35 degrees, yes. Yeah. So we can see here the angle UYV is 35 degrees because it's subtended by UX, which is this chord over here. So that's how we know that this is 35 degrees. Therefore, angle UVY is equal to the 180 minus the 35 plus 90. That's what they was going for, and
Yeah.
and that's how I get 55.
Yeah.
Right, well look at that. 1, 2, 3 marks. But you would only get the full marks if you had explained everything. Yeah? And we didn't even explain that. We had to put here, the last explanation is angles in a triangle equal 180 degrees. Yeah, so make sure you put your reasons. These are the actual theorems that you're supposed to know, and you have to show them that you know it. You have to show them that you know it, otherwise you wouldn't get the full marks. So good job with that 55 degrees. I actually wasn't going to do it like that, but that way actually worked out to be the easier way, right? O, U, W, O. So U here, W here, O here. So now we're looking for this angle. How are we finding that angle? Well, this is pretty easy. We could see here that UWO, that gives us this big triangle over here. Right? And with that big triangle, we could see that this is 90 and this is 70. So we could just say that angle UWO is equal to 180 from the big triangle minus the 90 plus the 70. Same kind of reasoning, which is what? Right, very good. So we have 20 degrees here, and that is why, because angles in triangle, let's call it OUW, equals 180 degrees. Alright, so try to be as short and concise as possible. You don't have to write a big paragraph. You can see that I'm using abbreviations and symbols as well. Right? So we have here 20 degrees. Let's just add that to the diagram. So you see that the diagram is getting plenty full of information now. 20 degrees over here, right? Name the triangle in the diagram which is congruent to triangle, right? 1 mark, 1 mark. So I guess that is just an answer, right? So we have the triangle ZOU. So ZOU. So what is the triangle that's congruent to ZOU? Yeah, XOY, this one over here, and we can see that congruent means they're pretty much the same angle, right? They're pretty much the same triangle, right? So the answer for this one is the same as XOY. And YXU. So Y, oh god, this is really easy. XU is the same as this here. Right? Those two are congruent because they are subtended by the same chord. So therefore that is equal to UXZ. Yeah? UXZ. That big triangle there. The diagram below, not drawn to scale, they are never drawn to scale, so don't ever measure anything. Shows a quadrilateral. I can see it's a quadrilateral in which QS is 7 centimeters. So QS is 7, I'm seeing that. ST is 10, seeing that. QT, the name of my kitty is Cutie Mao. And QT is 8 centimeters. Angle SRQ is 60 degrees, so we can see that here. And this angle is 40 degrees, we can see that here. What do we want? We want to calculate the length of RS. So we have all of the information, and they say I want the length of RS. Okay, so any ideas? What could we do for that? Essentially, this is going to be maybe a sine rule or a cosine rule kind of business. We
I use the sine.
The sine rule, right? Very good. There's no problem because we have this side and we have the opposite angle. We have this angle here and we want this side, the opposite side. So we can see it's a side angle thing. So let's call this small r, and this is the angle r. And let's call this small q because this is the angle q. So we can see that q over the sine of the angle q is going to be equal to r over the sine of the angle r. So we want to find q, so therefore q is equal to r over sine r multiplied by sine of q, okay? Which is r, which is 7 all over the sine of 60, which is being multiplied by the sine of 48. So q is equal to 7 divided by sine 60 is that multiplied by the sine of 48. Did you all get around 6 centimeters? Nice. And now let's check out the measure of the angle QTS. So that is this angle over here. I want that angle. I have the 2 sides around it. In fact, I have all 3 sides. So I'll automatically be thinking cosine rule, right? So the cosine rule, I want that angle there. So that'll be the cos of t. That is what I want. So that means that this side is no longer the side R, this side is now the side T, because it's opposite the angle T. Right? This is the side S, and this here is the side Q. So I want the cos of T, and with the cosine rule, I know that whatever the cos is, the side have to come over here. T squared is equal to S squared plus Q squared minus 2SQ. Yeah. So that is your cosine rule. So whatever this angle is here has to be the same as the side on the other side of the equation sign, and then the other two sides just go inside of this. You can see it's a little bit of Pythagoras theorem inside of there. So that is your cosine rule. So we can see here that T is 7 squared is equal to S is 8 squared plus 10 squared minus 2, 8, 10 cos of T. So 49 is equal to 64 plus 100 minus 20 times 8 is 160 cos T. Yeah, 22, 8 is a 16, yes, right? So now I have, let me just take this and fling it over. That's 164. So I'm gonna fling it over to become 49 minus 164 is equal to minus 160 cos T. So 49 minus 164 is 115 minus 115 is negative 160 cos T. Now I just fling over this, so I could get cos T is equal to negative 115 divided by negative 160 is equal to this kind of stupid looking number here, 0.71875. Therefore, T is equal to the cos inverse of 0.71875, which is cos inverse of the answer is 44.1 degrees. We could call it 44 degrees. So the table shows the ages to the nearest year. And did you do all of these questions, Scotia? Did you reach all here? Okay, you stopped on this page, right? So the table shows the ages to the nearest year, right? And I see that we're dealing with grouped data here, ages 40 to 49. Persons who visited a clinic in a particular week. So in that particular week, 4 people in this age bracket. We had 11 people in this age bracket. We had 20 people in this age bracket. Right? And what is the cumulative frequency? Well, we know cumulative frequency is just a matter of adding, right? Adding what came before. So this is the frequency of people that came before, organized by age brackets. Right? The frequency of people that came, and we could find the cumulative frequency. So 11 plus 4 is 15. What do you think gonna come here? So what we say in there is that anybody below this age bracket is only 4 people. Okay? We have this age bracket. Anybody below this age bracket, well, that's 11 plus 4, which is 15 people. Yeah. Anybody below this age bracket, well, that is 20 plus 11 plus 4, which is 35 people. So that is what cumulative frequency tells us. It's a real important thing, right? So I could tell that below the age of 60, I have 35, well actually no, 15 people below the age of 60. Yeah? Or below the age of 69, I have 35 people below the age of 69. Yeah? So copy and complete the table to show the cumulative frequency. We already did that, so we got 2 marks there, 1, 2. Right? Using a scale of 2 centimeters to represent 10 years on the x-axis, 1 centimeter to represent 5 persons on the y-axis, draw a cumulative frequency curve for the data. Right? So a cumulative frequency curve is not a normal distribution curve. The normal distribution curve looks like this, right? And that's what you get from frequency. So if you plot frequency, you can see you start small with 4, right? It swell big in the middle, right? And then it going back to a little bit in the end. Yeah. So if you plot frequency alone, you will get a normal distribution. If you plot cumulative frequency, a cumulative frequency curve is supposed to look like this. Yeah. Because you can see that in a cumulative frequency curve, you see how the numbers start small and then they get big and then they get back small, right? But in this one, the numbers start small and then they just get bigger and bigger and bigger and bigger. Yeah, so that's how a cumulative frequency graph is supposed to look. And at the end of the day, I will just do a sketch of it. They say here 2 centimeters to represent 10 years. Right, so I will just draw, let me just say this is 0. So let's just say this is 1. 2 centimeters to represent 10 years. So that's 10. Oh, I don't need to start at 10 actually. That's kind of crappy. I need to start at what? 40, right? So my x-axis doesn't have to start at 0, right? Is it the x-axis? Yes, the x-axis, right? So my x-axis doesn't have to start at 0, right? I could start here on this first one with 40, right? And then every 2 centimeters to represent 10 years. So this will be 50. And then on the y-axis, I'll have the same measurements, 1, 2, 5, and 1 centimeter to represent 5 persons on the y-axis. So 5, 10, 50, and there's a maximum of 50 people total, and you can tell the total from looking at the last number of a cumulative frequency curve, and you just plot your points, right? And when we plot in the points, how is it that we're supposed to plot this now? Right? Draw a cumulative frequency curve for the data. What age are we supposed to use for this? Right? What are we, you know, what, did we do this correct? Yeah? Because when we have 4, right, 4, are we going to put that 4 where? On the 40, on the 45, on the 50? Where are we going to put that 4? So we can see here that we have 4 people. So 4 people is about there. And when we cut across to the x-axis now, where do we put those 4 people? Or do we put them on 40, on 50, what? No, the 4 people are on the y-axis here, right, below 5. But when I'm coming across on the x-axis now, where is the point going to be? Because 4 people are between 40 to 49. So from 40, do I put the point on 40, 44? Or do I put the point on 45? Where do I put the point? What do I put? What do I do is I take the midpoint. So I find the midpoint of each. When you're dealing with grouped data, yeah, you find the midpoint of each. So the midpoint of this, and remember, how do you find the midpoint? Is you take the lower boundary and the upper boundary and divide it by 2. So the lower boundary is 39.5. So actually we could call it 45 if you want, yeah. And we just take the midpoint of each one. 45 for just for simplicity's sake, and then this will be 55. Right? And this 55 midpoint will actually represent this, yeah? And then this will be 65, 75, 85, 95. Well, we don't need 95, right? So what I did there was I actually took the midpoint of each class interval and I put that there on my cumulative frequency curve. So now the first number on the curve is 4, and I could take that 4 and plot it on that 45 because that 45 represents this whole group. You understand? So this 15 is going to come on the 55. The 35 is over here. That is going to come across to what? Help me out now. 65. and then 75, what we're going to is 47. So 47 is about here, and that's going to cut across to 75, and then 85, well, we have the 50, so 85 coming here, and that pretty much looks like an almost perfect cumulative frequency curve. Right, so a cumulative frequency curve does definitely look like that when it comes to tapering off at the top there.
And it was just
yeah, right. Because 20 is just the highest frequency in terms of the age, right? That is the most most people were around that age. Yeah. So now use your graph drawn above to estimate. Estimate the median age for the data. What is the median age for the data? How do we find median age? Yeah, the one in the middle of what? The median age, right, will be, well, we had to find which group is the median. Yeah. So at the end of the day, when we look here now, right, we look at the cumulative frequency. Which group is the median? Right? Is the median 25? Because we have the total here, 50 people. Right? So we know half of 50 people is 25. And but where is 25? Is 25 in this group, or is 25 in this group? Yeah? We could see here that 25 will fall pretty much in this group. Yeah, and we could actually look at that over here. If we plot 25 and we come down, we could see that basically the 60-year-olds are 25. So what they say, the median age for the data, 60 years. Right? The probability that a person who visited the clinic was 75 years or younger. And I'm not even, we did probability, yeah, we did. The probability that a person who visited the clinic was 75 years or younger. How do I find probability? Right? I take the amount of people and I put it over the total amount of people, eh? Yeah? Right? So 75 years or younger, if we use this, they say use your graph, right? So 75 years, and this is just an estimate because my graph is horrible, right? We could see there that it'll match up with around the 47. Yeah? So the 47 now, that means that 47 people, right, are 75 years or younger. That's the majority of people. Yeah. So there's a high probability that if you choose somebody at random, you will get somebody who is 75 years or younger. Yeah. So now you could just say, well, the probability of 75 years, actually, we have an easier way to write 75 years or younger. I could say less than or equal to 75 years. Right? Is, well, we can see that 47 people are less than or equal to 75 years, right? All over the total amount of people. So that is 47 divided by 50, 0.94, which is a very high probability. Remember, certainty is if you have a probability of 1, then that is absolutely certain to happen. So you can see that it is almost certain that you will get somebody who is above 75, younger than 75, right? Draw lines on your graph to show how these estimates were obtained. Well, that is what we just did. Using a ruler and a pencil and a pair of compasses, construct PQR with, and remember, before you construct anything, you should draw a sketch to get an idea of what's going on, right? So PQ, why did you do that? PQ is 8 centimeters, PQ, right? PQR, so that Q there is 60 degrees. So 60 degrees is look like about that. That is 60 degrees, right? And this angle QPR, this is 45 degrees. So 45 degrees is like half a 90. So this is 45 degrees, right? 60 degrees is greater than 45 degrees, so this should be greater. Let me see, if this is 90, this is 45, and this is 60. So this one should definitely look bigger. So let me draw it over. That was horrible. So the first thing you should do is draw your sketch. So this is P, Q, 8 centimeters. This here is 45 degrees, so that'll be looking so-ish, 45 degrees. This here is 60 degrees, so it should be a little bit bigger, 60 degrees like that. And I guess they will meet there at R, PQR. Yeah, so the angle QPR is 45, and that's it. And they want you to state the length, measure and state the length of RQ. This one here. So yeah, first you had to construct this and measure and state the length of this guy over here. How long is he, right? So let's go to the construction tool, and in the construction tool I wouldn't be able to see the question, so I'm hoping that you guys could help me remember the question, right? Alright, and now Soraya, I don't think you'll be getting construction. So the first thing that we had to do is, I know that I have the line PQ, which is 8 centimeters to the bottom there. So what I'm going to do is I'm going to construct a line PQ. So I'll draw a line longer than 8 centimeters. I will mark off a point P. I will take my compass and I will put it at that 0, and I will measure 8 centimeters to be about that. Let's see if I can get it a little more exact. And I will lock my compass right there. I will come to the point P, and I will cut an arc here, and then I will come over here now. No, I don't want to do that. Right. And I'll cut an arc here. So this here is the point Q, and this here is 8 centimeters. So the first thing I did was constructed my line, my line, right? Then I know I want 60 degrees on this side, and I want 45 degrees on this side. I should have drawn this line a little longer, you know, to get my 45 degrees. I might have to just extend this line just a little bit, right, to get a 45 degree angle. So to get a 60 degree angle is pretty easy. I just put this point here. I open my compass to any length, lock it, draw an arc, then come from this point here and cut that, and that will be 60 degrees. So I could just connect these two like this, and you could actually just measure that. Well, actually no, I don't know if that is the length of the triangle. I'm not sure, right? So this here, and let's check it and see if it's 60. Yep, it's 60. Nice. And then I have to make my 45 here. Now you can see I made a mistake. The mistake I made is I put the P a little too close to this end, because to make the 45 I had to construct a 90 first. Yeah, and that 90 is kind of tricky for me to do. So what I'm gonna do is, let me change my ink so that it'll be easy to see. I'm gonna put this here, and to construct a 90 I'm gonna open it out to, let me just say about there, because I don't want to go off the page. I'll cut there. Oops, I hate this thing for that. Right. No, stop. Alright, okay. And I'll cut here. Then now, I'll come from this point and I'll open it a little bit more than halfway. So past this P point here. And then I will make a cut like that. And then come from this point with the same compass opening. Oops, come on. You can do it. Yes. I'll make a cut there. And this line here is 90 degrees. Right? And now we have to bisect the 90 degrees, so I'll do that in a different color. I'll do that in blue this time. So I'll come here from this point and I'll bisect it like how I bisect any. So I will open my compass to any length. Alright, I'll do it. Come on, any length. And I'll cut both lines. I'll cut this one and I'll cut that one. And then I'll keep the same compass opening from this point here. And I will make a cut like this. And then I'll come from this point here. And I will make a cut like that. And this here should be 45 degrees, and I'll extend it. So you could see here that this point here is the point Q. So we have our triangle. Notice all of the construction lines, right? You're leaving all of the construction lines there. That is where your marks come from. The instructors will be looking for this line here to make sure that you draw your 90 degree. You know, so this is 45. This here is 60. And now let's measure. How do I turn this? Oh yes, I can turn it like that. Yay, it's turnable. And we can see that that's about 6 centimeters. Even though I'm not exact on the line, we can see that this is 6 centimeters. Right? So everybody cool with this question? Easy, right? The diagram not drawn to scale shows the cross section of a prism in the shape of a sector of a circle, center O. Right? The cross section of a prism in the shape of a sector of a circle. So a prism, I guess, in this thing looking like this. So that is the prism that they're talking about there, three-dimensional shape. And they're giving you the cross section of it. And it's the shape of the sector of a circle with center O, right? And radius 3.5. I could see that. The angle at the center is 270 degrees. So that means that this here is 270 degrees. And they're telling us for some reason to use pi as 22/7, right? So calculate the length of the arc ABC. So they want the length of this here, and that is easy. What I'll do is I'll calculate the circumference of the circle. Alright, circumference of circle is equal to 2 pi r. Therefore, the length of arc ABC, that arc ABC is 270 degrees out of the full 360 degrees. So it will be that fraction 270 of 360, that fraction of the circle, so that fraction of the full circumference will give me the length of that arc. So therefore arc ABC is equal to, well, 270 over 360 is 3 over 4 into 2 times 22 over 7 times 3.5, right? So 3/4, and you can see it is 3/4 of the full circle, right? So that would give us 3 over 4. Let me just do that again. Y'all seeing any mistakes there? No mistakes, right? 2 pi r 22 over 7 multiplied by 2 is equal to 7. What? 6, 7. What? Y'all seen any mistakes there? That looks okay to you? You got 22. I feel like I'm doing something wrong. What am I doing wrong?
That's good.
Alright, what am I doing wrong? Okay, well let's see. Something off here. So the circumference of the full circle, 2 multiplied by that. So that gives me 44 over 7 multiplied by 3.5, which is 44. Oh, come on. Stop it. 44 divided by 7 multiplied by 3.5. 22, yeah? So 22 is the full circumference of the circle. But I don't want that. I want this. So therefore the arc ABC is 270 degrees of the 360, which is 3/4 of the full circle. So it'll be 3/4 of the full circumference, which is multiplied by 3 on 4, 16.5. This looks a little bit better. The perimeter of the sector OABC. I confused. I think they want the perimeter of the whole thing, right? This entire thing like that, right?
Yes.
So therefore that would be the 16.5 plus 3.5. So I take in the 16.5 and I add in this 3.5 and this 3.5. Right? So that will be plus 3.5 by 2. 23.5, you got that?
Yes.
Lovely. And the area of the sector. Well, I'll just do the same thing. I'll find the area of the circle, which is pi r squared, which is 22 over 7 into 3.5 squared, which is 3.5 squared multiplied by 22 over 7 to the 8.5, and then therefore the area of the sector is equal to 3/4 of 38.5, which is 28.8, 28.9. You got that? Alright, 28.9. Scotia, you okay with this stuff? A prism is 20 centimeters long and made of solid tin. Well, I don't care if it's made of solid tin. So they say here that we have this prism here now, which is what we just calculated. So we have this prism, and what we just did, we just calculated the area of this sector here, and we found the area of the sector to be 28.9. So the area is 28.9. And now they're telling us that the prism is 20 centimeters long. So this is 20 centimeters long. They want to know the volume of the prism. And remember what I told you. Apart from a couple of very special shapes, like a pyramid and that kind of thing, you know, apart from these kind of shapes and a sphere, which you'll hardly get there, you'll hardly get these kind of shapes, right? But once you're dealing with anything cylindrical, in order to find the volume, you just literally take the area of the base and you multiply it by the height. So therefore the volume of the entire cylinder would be the area of the base multiplied by the height. So this multiplied by 20 gives us 577.5 centimeters cubed. That's what you got. Anybody? Shizzy? 580. Let me just see. Maybe. Oh, okay. You just put the volume as 29. Okay, sure. Multiply by 20. I'll get 578. You get 580. Well, that's a huge error, though, in terms of. I mean, they'll give you it correct, because they'll know that they'll know that is because of how you rounded it up, right? Did they say round it up to whatever? No, right? But in this one, they say in here to the nearest kilogram. So let's just call it 577, 580. All of that is around the same, right? But be careful, don't just round up things, man. Use your decimal place. The more decimals, the more accurate you get, right?
Yes.
The mass of the prism to the nearest kilogram, given that 1 centimeter of tin has a mass of 7.3 kilograms. How are you gonna do this? No, well, no, not no. The word here is solid.
Oh, yes.
Made of solid tin, which means that it's not a cylinder that holding anything. You know, it's not empty. It's actually solid tin right through. Yeah. So because it's solid right through, means that you could have done that. You could have said, well, okay, if it's solid right through, well, then this is actually the volume of tin that we have. The volume of tin that we have is centimeter cubed, right? So therefore, 1 centimeter cube has a mass of that, then that will have a mass of that times that, what's the answer you got? Right. Now, what do you think? How heavy do you think this thing would have weighed? And let me just give you all the actual. You don't have to work it out, but tell me how you would work it out. How heavy do you think this thing would have weighed if it was empty? If it was empty, yes. So if it was empty, well, then they would not give you a cube here. They would have give you a square, then. Yeah, and you would have had to find the surface area. So you would have to understand that the surface area of this shape will have one side looking like that and the other side looking like that. Right, so that is the two sides on this side and on this side. Then you have this rectangle here, which will be 20 by 3.5. So you have this rectangle, you have the same rectangle 20 by 3.5 at the bottom here. But then you will have this all the way around that will end up working out to be, well, it'll be 20 long. So it'll be 20 long. This is 20 by 3.5. So this will be 20, but then when you roll it out now, 20. And this here will actually be the length of the arc around it. So the length of the arc around it is 16.5. So I guess it's shorter than the 20. So maybe I cut it here. Yeah. So yeah, and then you could have found out, you know, by the area of the tin and how much the tin weighs if it was empty. So I just wanted to make sure that you could have taken or talked about taking a cylinder and breaking it up in order to find the surface area, because that is a question that they could very well ask. So the universal set U is defined as a set of integers between 11 and 26. And I don't like their wording because I'm not sure if it includes 11 and 26. They just say the word between, you know? So I'm going to, between means not including. I'm going to assume that it's not including 11 and 26. So therefore the set U is the set of 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. This is the set U. Right? A and B are subsets of U such that A are the even numbers and B are the multiples of 3. Right? So I know even numbers are easy enough to see here. Right? But let's mark off multiples of 3. So 12 is a multiple of 3, 15, 5 trees are 15, 6 trees are 18, 7 trees are 21, 8 trees are 24. So those are the multiples of 3. Right? How many members are in the universal set? Well, we could see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 members in the universal set. List the members of the set A, the subset A. So A are the even numbers 12, 14, 16, 18, 20, 22, 24. B are the multiples of 3, so that's 12, 15, 18, 21, 24. You can see there that you have some intersection taking place. Draw a Venn diagram to represent. So we have the entire of U here. So I'll draw U first. Right? And let me just draw A. And we can see here that A and B will intersect. So I will just draw B like this. Right? A. So let's call this one A since it's bigger. And B. Right? And let's put in the intersection first. So we have 12 in both of them. We have 18 in both of them. And we have 24 in both of them. So therefore your 12, your 18, your 24 going over here. And now I'll follow the rest in A, 14, 16, 20, and 22. And the rest in B will be 15, 21. And then the rest will be in the outside. So I'll have 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25 will be outside. That is it.